All right, today we are continuing with solving rational expressions. So just like yesterday, we're going to do the same processes. Some of these are just a little bit more in depth. So I'm looking at my denominators, right? I'm trying to make them all the same by finding the least common denominator. So what I'm going to do first is see if I can factor, trying to break this down. So for the first one, let's get rid of the line for a second. All right, so for the first one, if I take out a 3, I get w minus 1. Then I have w minus 1, and then over here I have 9, or, it's 3 times 3. So if I'm looking for my LCD, I have 3, w minus 1, right? There's another w minus 1, so this is a repeat, so I don't need to write that. And then one of these 3's, right, is already here, so that is also a repeat, so I don't need to write that in my LCD. However, this guy, right, I have to put there as well. So what's my LCD? If I just wanted to simplify it a little bit, it would be 9 times w minus 1. And the reason why I'm not, distributing the 9 here is because in the next step, it's a lot easier if you just kind of keep it sort of broken apart instead of distributing it. And I'll show you that in a second. All right, so I've rewritten the problem just with the first denominator factored there, because what I'm trying to do is I'm trying to get all the denominators to be this LCD. So for the first one, what would I have to do to make this look like this? Well, I'd have to multiply by the 3, so that I would be left with 9 w minus 1. Whatever I do on the bottom, I have to do up top. For the second one, I would have to multiply this by 9, so I'd have to multiply the top by 9, right? And then lastly, I would have to multiply by w minus 1. Whatever I do on the bottom, I have to do up top. Okay. Now, all my denominators are the same, which means I can get rid of them, and what I'm left with is 39 minus 9 equals w minus 1. Okay, so all I have to do now is combine like terms over here, and let's distribute here. Okay, now hopefully you see that we have a quadratic, which means I'm going to bring everything over to one side of the equation because we want the quadratic set equal to 0. The reason why is because if it's set equal to 0, I can factor. Luckily, my a is 1, which means what are my factors of c that add up to b? My factors of negative 30 that add up to negative 1, right? So I would be left with w minus 6, w plus 5. Okay, so I would get my answers being w equals 6 and w equals negative 5. Now you want to go back into the original problem, make sure that there is no divide by 0 errors or anything like that. So if I check w equals 6, I would get, kind of running out of room here. I'll write it down here. I would get 13 over 18 minus 3 minus 1, 6 minus 1 equals 6 over 9. So I would get 13 over, oh geez, I'm running out of room here. 13 over 15 minus 1 over 5 equals 6 over 9. If I make this a 15 by multiplying by 3, I'd have to multiply this one by 3, and I would get 10 over 15 equals 6 over 9. Just to, so everybody's on the same page. When you get down to something like this, some people look at that and they say, oh, they're not the same fractions. But if you reduce both of them by dividing by 5, you would get 2 over 3. And if you divide by 3 here, you would also get 2 over 3. So that is actually an answer. That's good. For negative 5, it would be 13 over, let's let's go back to the original problem. I think it's 3 times, right? Yeah, 3 times negative 5 minus 5 is negative, 10. Negative 15 minus 3 minus 1 over negative 5 minus 1 equals negative 5 over 9. That would give me 13 over negative 18 minus 1 over negative 6 equals negative 5 over 9. How would I make this the same? I would have to multiply this by 3. That would give me a 3 here. So that's negative 18. This is a negative. All right, minus. Now this is going to turn into a positive. So now I have, because technically if I move this up top, that's okay to do. You can move the negative up to the top because when you're adding fractions, you're combining the numerators. So I'm just going to do that, which would give me a negative 10 over 18 equals negative 5 over 9, which is true, but just to make sure everyone's on the same page, if you divide this by 2, you would get, right, what you have over here, which is good. Okay, so that is also an answer. All right, next, 11. Hopefully this will be nice and easy. If we're looking, okay, we do have the same things here and here. However, we do not have the same denominator here. We have a 1. So we just need to make all of them the same, which means I need to multiply this guy by x plus 3. So if I multiply that by x plus 3 on the bottom and on the top, I would be left with x plus 6 over x plus 3 equals 2 times x plus 3 minus 5x plus 12 over x plus 3. Now that I have all the same denominators, I can get rid of them, and I'm left with x plus 6 equals 2x plus 6 minus, and you want to make sure, and this is very important, when you're subtracting by a fraction and you get rid of the denominators, it's subtracting 5x and also subtracting this 12, right? So you could just distribute this negative and get negative 5x minus 12, but that is a big thing. That's something, this guy right here is going to mess a lot of you up if you're trying this on your own. So I get x plus 6 equals, if I combine like terms, negative 3x, negative 6. I'm going to move everything, switch up the color here. Move everything to one side of the equation. Okay, and I get my answer. However, if I plug that back into, right, negative 3 plus 3 is going to give me 0, which is, you can't divide by 0. So since you can't divide by 0, x minus 3 is not a solution, which means, right, there are no solutions. All right, again, we're trying to get all the denominators the same. So if I factored, to make it a little more easy to see, what are my, what's going to be my LCD? First I have C times C minus 4. Ooh, we got a repeat. Okay, so I don't need to write it. And then this guy is a 1, which means, again, anything times 1 is just going to be itself. So my LCD is just C minus 4. Okay? All right, so now I rewrote the problem. I'm just going to try to make all the denominators this LCD. So my first one's already the LCD, so I don't have to mess with that fraction. The second one, I need to multiply this by a C. So I need to multiply the top by C. And then here I need to multiply the whole thing by the LCD on the top and the bottom. Okay, I kind of skipped ahead and rewrote it just to save a little time. Now that I have all my LCDs the same, I'm just going to rewrite. I multiplied the C and the C to get the C squared, and then I distributed the C into here to get this guy as well. Okay, so what I'm left with is 3C minus 2 equals C squared minus C squared. And since I am subtracting a negative 4c, that turns into a positive 4c. And now I'm just going to combine like terms to solve the equation. So I get 3c minus 2 equals, hey, wouldn't you know it, I don't actually have to end up factoring on this guy, which is nice. I thought I would have to. I'm just left with the 4c on this side. Subtract 3c. Left with negative 2 equals c. That's my answer. Let's just go back in and check and make sure that works. If I put it into the first equation, I would get negative 6 minus 2 over 4 plus 8 equals negative 2 over negative 2 minus 4, which is negative 6, minus 1. So let's look at this. We got negative 8 over 12 equals 1/3 minus 1. Sorry, I just did that in my head, but you know, if you reduce this, it's just going to be 1/3. So I would get negative, let's see, negative 2 over 3. If I divided this both by 4, right, I would get negative 2 over 3. Does negative 2/3 equal 1/3 minus 1? Yes, it does. But just to make sure, in case you're kind of lost, if I make this 1 have the same denominator as 1/3, it would be 3 over 3. Does negative 2 over 3 equal 1/3 minus 3/3? Yes, it does. This is my answer. I am done.